4x minus 2x minus 3 in absolute value. Okay. Good. So in this particular situation, we only have expression, we only have one absolute value. This is where I start. And I copy the same thing 5 times. I copied it 5 times because it's the absolute value, and that's all I have to do for now. Then I will simplify and also solve this inequality. I will not solve this one. So then 2x minus 3x greater than equal to 3 halves, negative 2x plus 3 for x less than 3 halves. Is this okay so far, everyone? Please say no if you have any doubts.
Why didn't you choose to solve the thing marked down?
Because if this is greater than or equal to 3 halves, this cannot be anything else but less than 3 halves. If you solve it, you may come up with something else, and then it's going to be a huge error. So that's why I'm insisting do not solve the other one. There is no need. Once you have the solution for the first one, you already know the solution for the second one without solving it. Is that okay with everyone? Yes? Okay. So now we put everything together. For one absolute value, there is no need of the table. You do not need to use the table. You can if you want to. It doesn't matter. But there is no need. If you have 2 or more, you have no choice. Maybe there is a choice. If you come up with a different method, I'm fine. So we have 4x, so we have 2 options. For x greater than or equal to 3 halves and for x less than 3 halves. So the first option will be 4x minus this. And the second option will be 4x minus this. Is this okay?
Yes.
Please stop me if you have questions, anytime. Yes, please.
Was it? Oh, never mind.
I love it when my students answer their own questions. Yes, Mike.
So the 4x, the negative isn't distributed to the other two?
Negative is distributed here, and I get this. Negative is distributed here, and I get this.
Would it be plus 3?
So negative times 2x is negative 2x. Negative 1 times negative 3 is positive 3. Negative 1 times negative 2x is positive 2x. Negative 1 times positive 3 is negative 3.
Okay.
Better?
Yeah.
So now we combine like terms, and we get 2x plus 3x greater than or equal to 3 halves, and 6x minus 3 for x less than 3 halves. Any questions on this? Yes, please.
You said in the last class that we can put the equal to sign with any
Either one.
Either one.
Just
so
once.
It's okay if I put it in the.
Just once. Now, just be consistent. If you always want to put it with the top, this is what is normally recommended, but it doesn't matter. You can erase it from here and put it here. Just be consistent so you don't forget. Whatever it is, I accept it. Mike, is this okay?
Yeah.
Other questions here or on this problem? Okay, Anissa, please. What problem is that?
The other one.
Oh, I'm sorry. I think Caleb was next. So sorry. Oh, you want to do the other one?
Yeah.
Yeah, we can stay on the same stuff, man.
I'm sorry?
We can stay on that.
Did you redo the first problem we did in class?
Yeah.
And you did not understand how it works?
I understood it now, but like the only thing that was confusing me with both of them was like the minus sign. Because the examples that we did were all like adding. I don't get the table from.
Oh yeah, you do?
No.
The table is not clear?
Neither would I.
Okay, so let's do it. Let's do it then. I think that the table is what it should be clear in this problem. The rest may be fuzzy, but that's just an opinion. Okay, are you with me, everyone? Yes? Yes? Okay, so obviously I have to do this. I have no choice. I have to write it 5 times. We understand this, right? We have that already. You shouldn't copy it because I'm sure you have it already, right? Right? This is, it should be in your notes by now. Negative x plus 1, x less than 1. The same thing with x plus 2, because if the problem was just the minus, it means that you already have these two simplified without the absolute value. And all we have to do is just put them together, right? Okay, so x plus 2 greater than or equal to 0, x plus 2 the fourth time, x plus 2 the fifth time. Simplified into x plus 2 greater than or equal to negative 2, negative x minus 2 for less than negative 2. So far, so good?
Yes.
Okay, and now let's create that table. In the first row, we always have the variable in the problem, x, that goes from negative infinity to infinity. In the second row, we have the next in line. And in the third row, we have x minus 1 minus x plus 2. Of course, what we are really interested in. I'm not interested in x. I'm not interested in the absolute value of x minus 1 or x plus 2, but I'm interested in the whole expression, correct? Yes, please.
All right, I have a question.
Yes.
So when we did the absolute value of x plus 2,
Yes.
that minus on before is not matter until like we do the table at the end.
Say that again, I'm sorry.
So it's the problem is absolute value of x minus 1 minus the absolute value.
Oh, I'm not considering anything. I'm only putting everything together and you'll see what happens next. Very good question. Very good question. Okay, so which numbers go in the table and what is the correct order? Very good, negative 2 and 1. Do we see 3 subintervals? We do. Okay, now I go back and I read. Let's read this. And this is probably where we should emphasize. The absolute value of x minus 1 can be replaced by x minus 1 for all numbers greater than 1. Do we understand my reading? Is that okay with everyone? Yes, Caleb? The absolute value of x minus 1 can be replaced by x minus 1 for any x value greater than or equal to 1. We agree? I see greater than or equal to 1 only one interval. I'm going to write x minus 1. For any number greater than or equal to 1, I have x minus 1, and I copied it. I continue reading. The absolute value of x minus 1 will be replaced by negative x plus 1 for any number that is less than 1. Any number that is less than 1, it happens that I have 2 intervals. I'm going to write it twice. Oh, yes, of course, of course. Thank you, thank you, thank you. Is that clear now? All I did is took this information and put it in the correct spot in the table. Is this better, everyone? The absolute value of x minus 1 is replaced by x minus 1 for x values greater than 1. It's replaced by negative x plus 1 for any number to the left of 1. To the left of 1, negative x plus 1. Is this okay? Are these numbers less than 1?
Yeah.
It happens that I have 2 intervals. I have to write it twice. I only copied from here. I just summarized the information in the table. I didn't do anything else. I didn't make any changes. Is this okay? I read again. The absolute value of x plus 2 can be replaced by x plus 2 for any number greater than negative 2. Any number greater than negative 2, I will have x plus 2. It happens that I have 2 subintervals. I'm going to write it twice. The absolute value of x plus 2 will be replaced by negative x minus 2 for any number less than negative 2. Negative x minus 2. I only copied this information and this information in the table. I did not change anything. Is everyone okay with this step? Yes? Finally, is it clear now? Okay. So now, negative x plus 1 minus x minus 2. So it will be negative x plus 1 plus x plus 2. I have to perform this operation. Negative x plus 1 minus x minus 2 because I have minus. And then x minus 1 minus x minus 2. All you have to do is distribute the negative to the second half of the problem. That's all you do. It's either plus or minus. If it's minus, you distribute. If it's plus, you just copy. Is this okay? So therefore, final answer, the absolute value of x minus 1 plus the absolute value of x plus 2 has 3 possibilities. The first one will just be 3. The second one will be negative 2x minus 1. And the last one will be negative 3. All I have to do is just find the intervals, and I'm done. Whatever you want. So, of course, this answer is for this. So I will write less than or equal to -2. This answer is for this. -2 less than or equal to 1. And this answer is for this, which means greater than 1. If you discover a different method of doing this, please use it. If that different method is easier for you, I think that this is super self-explanatory. But it may not work for everyone. So you may find a different method, and I will be very happy to see it. Is this better now? Yes? Okay, so in that case, you have the rest of the problems to finish. Since I think we answered all questions right now. So you have 1, 2, 3, 4, 6, 8, 9, 10, and 11 for Tuesday. Check the answers in the back and see what happens. Okay? Perfect. Next question. Anything else you have for me? Anything? Yes,
Yes.
I'm ready.
So on the other side,
Yes?
1, 6.
Yes?
I had number 8, number 11, and number 14.
If they are the same, choose, because we would not be able to finish today.
But yeah, I mean, I think
Just
if
choose
anyone
whatever
has
you want.
questions on those, maybe we have perspective.
I don't know what they are, so can you please dictate any?
So what's number 11?
Let's do number 11. Okay, perfect. Anyone has number 11 for me?
Oh, sorry. Would you like that?
Yes, please.
I believe it was the square root of x minus 3 equals x minus 5.
X minus?
5.
Perfect. Every time we are asked to solve an equation, we have to identify the equation. So can anyone tell us what type of equation is this? It is a radical equation. Second question I ask myself is, how many radicals does it have? One. Is the radical isolated? Alone on one side, alone, nothing else touches it?
Yes.
Good. So then what is my next step?
Squared.
Yes, I have to square, and I square both sides as one unit. Not square term by term. You cannot say just x squared and 5 squared, right? You square the left-hand side as one unit, and you square the right-hand side as one unit. Perfect. Can anyone give us the squared form of the left-hand side? Can anyone give us the square form of the right-hand side? And remember, we have an agreement on this from the first day of classes.
X squared minus 2x into 5 plus 25.
Very good. X squared minus 10x plus 25. We have an agreement. We signed it. You have it with you. So this is becoming now what type of equation? Excellent. So x squared minus 11x plus 28. I was going to say less than or equal to 0. Greater equal to 0. So we moved x and we moved 3. Can anyone tell us which of the 4 methods you would like to apply? Remember, we have 4 methods, but one of them is fast. Yes. How do I factor? Yes, very good.
Minus 7x and minus 4.
Thank you very much. So it appears that the equation has 2 solutions. However, I cannot put a big enough question mark in there. Why?
Because into with the 2, like,
Because we squared, yes. We use the principle that this is not 100% legitimate. Correct. And we have to check back in the original problem. Okay, which one? Let's check 7. 7 minus 3 is 4, the square root of 4 is 2. 7 minus 5 is 2. I will say yes for 7. Now I'm checking 4. 4 minus 3 is 1. The square root of 1 is 1. The right-hand side is -1. What do we conclude? No. Good. Is this clear? Perfect. Awesome. That's all I wanted to hear. I just want to hear the word crystal.
I just have a question about, so when you're squaring the square root,
Yes?
why would you have a plus or minus pop up anywhere?
Excellent question. Here it is. When you square 2, do you get plus or minus 2? It has to be a positive number. Whatever you square, you always get a positive number. If you square positive, you get positive. If you square negative, you get positive. So no matter what you square, the quantity has to have a plus in front. Mandatory. Now, if I take the square root of 4, that is only 2. But if I solve the equation, if you remember we talked about it last time, I should write this, which happens to have 2 solutions. But we don't write this step. We directly go to write plus or minus 2. And I'm emphasized, please do not ever consider that the square root of 4 is negative 2. The square root of 4 is only 2. The plus or minus come from this side, from the absolute value, not from this side. Is this okay? Perfect question. Anything else? A couple of semesters ago, a student of mine asked me in a calculus class, can you, professor, make the connection between this and this? And then I said, why didn't I ever present that and connect those 2 topics? And now I do. So your questions help me get better in my presentations. So do not ever think that a question is silly or refrain yourself for whatever reason of asking it. Because it really helps me and it helps you. Perfect questions. Anything else? Do we have anything else?
Could we just do one more problem?
Yes.
What are the 3 I had up there? What was the other one? Was it 13 maybe?
You have to read 11.
No, 14?
Okay. So this is from WebAssign,
Yeah, 14.
and this is from WebAssign.
Yeah, can we do 14 on those?
I'm ready.
Okay, so the square root of 3x plus 9 plus the square root x plus 4 equals 1.
Okay. So this is a note for my colleagues. Oh, we did one. Just to be sure. We did one with 2 radicals, right? We did one with 2 radicals. Okay. Okay. So that's a note for myself. Every time we have a radical equation with 2 radicals, it is easier to solve if we move one radical to the other side, if they are not already separated. Do I have to do this? No. It is wise to do it, though. So the square root of 3x plus 9, 1 minus the square root of x plus 4. Of course, the next step would be what we did last time with any radical equation. The left-hand side is easy, but please remember the right-hand side, you have to give me 3 terms. First term squared, please. Excellent. Minus 2 times 1 times the square root plus the square root squared. We are using our agreement from the first day of classes. First term squared minus 2 times the first times the second plus the second term squared. Now, as you see, if you start by solving the radical equation and squaring both sides, and both radicals go away, here they didn't, right? One radical is still there. You know you have a problem. You have made an error. So even if you don't separate the radicals, you will still have or end up with another radical in the end. I mean, at this stage. So now I have one radical. Everything else has to move to the other side. So I subtract x from both sides, this x, and I get 2x. And then I have 4 plus 1, which is 5, that needs to be subtracted from 9. So I am back to the first problem, number 11, in which I have a radical on one side, and an expression, a binomial on the other. So now I follow the same steps. Is it okay? Can you take it from here, or you want me to finish it? Yes, please.
One question.
Yes, please, please.
Would you divide?
Of course.
both sides by the
Absolutely. Not negative 2 by 2. There is no need. Why would I only have one negative term. If I divide by negative 2, I'll have 2 negative terms. What's the point?
So then to get rid of the negative.
Okay, I think we should finish it. I got it. So then we have x plus 2 equals negative the square root of x plus 4. It pains me when I see that some of you do not redo the problems we do in class, because that's the first step. That's the first step in the learning process. Okay, so now we square both sides. Can anyone give us the 3 terms on the left? Excellent. And can anyone give us the right-hand side? Very good. Luckily, these two go away. It's quadratic. X squared plus 3x equals 0. It's in descending order. Greatest common factor. Very good. And we expect 2 solutions because it's quadratic. And what do we get? Very good. X equals 0 and x equals? And I'll let you check. Okay? Please go back and check and see which one, yes, and. Okay. I would like to finish up this handout with an example for you. Is this better, Caleb? Every step? So please, I will remind you every time we meet, you must redo the problems we do in class first. I do enough problems for you to have a basic understanding of what you need to work on. If you don't understand those, it is very difficult to do homework, and it will take forever. Okay? So I would like to show you, although we're going to use the calculator the entire semester, but I like to put this aside and forget about it. Solving equations graphically with a graphing calculator. So I would like to choose, there are 10 problems here, and I would like to just illustrate with one of them. I think you have this handout. Or you can choose. The handout is in Canvas. I posted all of them. So with a graphing calculator, please choose any. So it's solving equations using the graphing calculator. Okay? It doesn't matter. They're all the same. So can I choose one, or?
Yeah.
We have it? Do you want to choose?
You can go ahead.
Okay, so let's say from this handout, I'm looking at the last page of the handout, let's say problem 9. Because we don't know how to solve this. Many other equations, we know how to solve algebraically. We really don't need to solve it with a graphing calculator. So we have here, let me show you. You may not have, you don't have the handout? No, okay. So, this is quadratic. I know how to solve it. I really don't need to solve with a graphing calculator. This is radical equation. I know how to solve it. I really don't need to. If you want, you can check. The absolute value, I know how to solve. This we're going to solve today after we finish this. This I know how to solve. This I know how to solve algebraically. This may be a problem. This I know how to solve. It's quadratic. I have the quadratic formula. There is nothing I can waste my time with a graphing calculator. This I don't know how to solve. And this I know how to solve. I punch in the graphing calculator and I'm done. So these are the only 2 problems, although this, we're going to talk about it today. Basically, I would say this is the only one from this bunch of 10 problems that I have no way of solving. I don't have a quadratic formula because it's cubic. I have no other way. There is one calculator that I like the most, which is TI-86. They don't produce it anymore. This is the only calculator that has the feature poly. You put the polynomial, any polynomial you want, you put the coefficients and gives you the answer after you press a button. But this does not. 84, 83, 81, 85. No, they don't. Only 86 has it. So I would recommend doing this problem together. Ready? Okay. So there are two possibilities here. One possibility is we put the function on the left-hand side and 0 on the other, or not put anything, in other words. Or we have, in some of the examples, in some of the problems, we've had a function on the left and a function on the right. In our example, I think we only have a function and 0. So in that case, I will punch in y equals the function itself, which is x cubed plus x minus 1 and I will go to second and calc. And in this case, I will use the feature 0 because I want to find the 0, right? The x-intercept of this function. In case I have a function on the left and another function on the right, which of these, which item from the menu will I pick? I will pick the intersect, correct. If I have a function on the left and a function on the right, I will pick the intersect. But since I have 0 on one side, I will pick the item on the menu of 0. So you can either scroll down or just press 2. So the function is graphed. I see that in the viewing window, I just wanted to show the viewing window, please. It's still working. Working hard. What do you think it's doing?
You press enter.
I did.
Try pressing enter again. It might actually come in.
I just want to see the viewing window. It doesn't allow me. Okay, never mind. So because I have not used the software just yet, I did not change the viewing window, which means -10 to +10, -10 to +10. Obviously, I see that the solution is somewhere between 0 and 1. The calculator will ask us for I have to stop it. I'm not sure what's happening here. I have to start from scratch. Okay, so it was x cubed plus x minus 1. Okay, second calc. I want to find a 0, but no, I want to show the viewing window. So the viewing window, since we already graphed the function, I can now change the viewing window because I'm only interested between -2 and 2. I don't care for anything else. And between -2 and 2, because I'm around the x-axis.
That's the x scale.
Oh, that's not what I meant. I meant 1. Thank you very much. -2 and 2. So I see the graph. I see that the x-intercept is somewhere between 0 and 1. I will go to second and calc. I will select 0, press enter. It will ask me for bounds. The calculator doesn't know what we really want. So the calculator now is asking me, okay, where do you want me to find the zeros? The 0. I'm going to say between 0 and 1. The left bound is 0. I'm going to press enter. The right bound, I'm going to put 1. And as you see, I don't want to guess. And the graphing calculator is giving us the solution. Of course, y is 0. and x is 0.6823278. Okay, so it appears that this cubic equation has one real solution and two imaginary. It has to have three, right? We know degree three solutions, but only one real and the other two imaginary. So that's all I really wanted to show you here. Now I just want to show any other one with two sides. Just how to enter it. Yes, please, Mike.
How do you know it only has two solutions?
Oh, first of all, it's a cubic polynomial. It must have three solutions. Not one, not two, not four.
No, you said it has two real and one imaginary. How do you know that?
It's a very good question. It's because of the graph. We're going to talk about these functions, polynomial functions, in the next chapter. Very good question. Together with rational functions. Yes. A cubic function has the same behavior as a linear function. So this one has a positive slope. So it comes from negative infinity, goes to positive infinity, and it can only cross 3 times. But this one happens to cross only once. So it cannot cross more than 3 times. Okay, so I'm just going to show you how to enter, let's say, problem 2. So in y equals, the left-hand side is 2x. And the right-hand side is 1 minus the square root of 2 minus x in parentheses. I like parentheses. The newer calculators don't need it though. Don't need parentheses. So I'm going to go to the viewing window or Zoom, and I'm going to use 6, the standard. And as you see, these are the two functions. The first one, I normally have colors in here, but they don't show. I don't know why. Maybe we don't have the software. We should. Okay, so I see that they intersect in a point, at a point. I'm going to try and change the viewing window because I really can't see what happens here. And graph again. Okay. Ah, much better. So they intersect, and obviously they intersect between -1 and 0. Now with second and calc, I will go to intersect, which is number 5. And it will ask us, is this the first curve? Yeah, the first curve is the one y1, 2x. I press enter, it jumps, the cursor jumps on the second curve. I'll say yes. I don't want to guess, just give me the intersection. So x is -0.25 when y is -0.5. So that's the other option. But you don't have to ever use this option. You can always move everything to one side and set it equal to 0 and only use the 0 feature. You create one function. So it's up to you. That's really all I have to say about this. Okay.
Are we supposed to have that packet?
Maybe I didn't copy it, but it is in Canvas. It tells you step by step how. Yes, Mike?
So does that mean that the 2 answers for that are -0.25?
This is an ordered pair. This is x and that is y. 1 point, ordered pair, x comma y.
So is that the answer or in the pair?
That's the ordered pair. -0.25 comma y. Yes.
So we're trying to find the answer.
So yes. So the intercept of that is x equals -0.25. Both functions equal -0.5, and that they intersect at the point -0.25 comma -0.5. But since we're asked to find just x, we will answer as -0.25. You're correct. Both of you, you're correct. Okay. So it tells you step by step what I showed you here. This handout. Okay. It is in Canvas. I'd like to finish section 2.6 and continue with section 2.7 with the inequalities. And also, I would like to look at this handout. You do have this. Too many handouts. That's all I can say. Probably here. Nope, that's the absolute value. It's right here. So that's 1, but I had 2. I had a small one and a big one. We'll find it. So we have one more type of equation here. to finish this handout, to finish the book. Okay, which is two types of equations: quadratic in form and rational exponents. Okay, so rational exponents. And
We still can't see.
oh, sorry. Okay, so we have not talked last time about this type of equations, and last time we did not talk about this type of equations. And that will end 2.6 with other types of equations. Okay, so equations, quadratic, in form. Equations, quadratic, in form. They're not quadratic, but they can be replaced by a quadratic equation. That's all it means. So let's take a look at 37. X to the fourth minus 10 x squared plus 9 equals 0. And then I'd like to look at one more. Okay, what type of equation is this? You will say polynomial, right? And it's polynomial degree
4.
Excellent. How many solutions?
4.
Of course. So now you can say, wait a minute. You're talking about quadratic in form and you're giving us a polynomial 4th degree. True. So please make a note, degree 4, solutions must be 4. So yes, this equation is not only quadratic in form, but also polynomial. Indeed. However, I noticed something important here. That if I denote this by t, let t be x squared, then I could denote this, because I cannot have t and x in the same equation, I could denote this by, do you all agree with that? Do we all see that? So now the equation becomes t squared minus 10t plus 9 equals 0. And you could say, wait a minute. You are changing the variable from x to t. You are creating a new equation. What happens next? Well, the solutions will be still given in x. But right now, I know how to solve this. I will solve it for t, and then go back and create two equations in x. They're much easier to solve. So can anyone give us the factored form of this? This is a procedure. It's called substitution if you want. We are substituting. I substituted x squared by t and x to the fourth by t squared. Does this method works always? Of course not. Of course not. Let's look at this handout for a second and the problem that we just looked at. I can't use that procedure here because if I denote this by t, this is not t squared. So I'm happy that this equation, in this equation, I have a quadratic in form type of equation and I can use substitution. But it doesn't always work. It always works for equations that are quadratic in form. At the core, they are quadratic, but they're not really quadratic, really.
So when you demote the t, you have to always explain like let t equal x squared.
Yes, you can use any letter but x. So with y, u, whatever you want. But you have to write this. You'll see what happens next. So can anyone give us the factored form in t? Yes, Mike?
T minus 9 and t minus 1.
So now can anyone give us the two solutions in t?
Equals 1.
Sorry. Okay, so now this is a new equation and this is a new equation, but much easier to solve.
1 squared minus.
I have to go back and replace t, but by what it equals to. What does t equal to? Indeed. So this is x squared equals 1, and this is x squared equals 9. And now we have either factoring or taking square roots. Again, how many solutions we expect total?
Four.
Perfect. How many we get from here? How many we get from here? When we take the square root. T equals,
X plus 1 is fine.
very good, and T equals,
9, negative.
3 to -3.
very good.
You mean X
Yeah,
instead of T?
wasn't it supposed to be
My apologies. Of course, X. My apologies. Yes, Robert?
You can put in the x squared in the previous step as well, right?
You could. Absolutely. If you see how to factor without using substitution, that's fine.
And
However,
did you mean 1 and -1? I did see.
Yes, there's one negative one.
Is there a negative hiding in there?
Yes.
yes, when we take square roots. Yes, of
No,
course.
she means in the
On the-
You didn't write it.
negative one.
Can get away with anything in this class. I don't want to. Thank you. My apologies. Good. So anything, everything clear here? Yes, please.
Is it a shortcut to see when you get T, just take your 4 solutions would be 1 in the inverse, 9 in the inverse? Is that a shortcut?
Not 9. You mean from here?
I see, I see where.
Is that okay?
Yeah.
Perfect. Let's work on one more, like let's say 38. 4. So these problems are from the book, and this is page 141, book, and this is page 141 from the book. Okay. T minus 1 squared minus 9 t minus 1 equals 2. The method is very useful, especially in this case. In the previous case, Robert is right. He said, well, just factor as if it's x squared minus 1 times x squared minus 9. That's fine. Perfect. And then you can continue factoring. I completely agree with that. But here, this is, I think, easier to use a substitution. So we'll say let y be,
T minus 1.
oh, of course, thank you very much. So the new equation is 4.
Y squared
Very good.
9y.
Exactly. Remember, we have 4 methods of solving quadratic equations. If factoring takes more than 20 seconds, forget it. Use the quadratic formula. We never complete a square unless we need to for other things like circle. And factoring, as I said, factoring, taking square roots, in this case, it doesn't work. Complete the square, absolutely not. I'm not going to go through those steps. And quadratic formula. So please give me the solutions. I want to show you, because I don't think I did this. I want to show you how to use the quadratic formula with the graphing calculator. So, negative b, in this case it's 9, plus the square root of b squared, parentheses, 81, minus 4ac. I have 2 minuses, so 16 times 2, 32. Close the, oh. Okay, close the parenthesis around the numerator, completely outside of the radical, and divide by 2a, which is 8. The other option is this. Now, okay, these are irrational numbers. I just want to see this. Did I copy this problem correctly? I don't know the answer. Ah, I didn't copy it correctly. It's minus here, so it's plus here. Okay, so I go back. Yeah, because then the x becomes more difficult to come up with. That's the only thing. So it will be minus here. That's the only difference. But it may make a huge difference, and it does. Okay, so it's 1/4. So y1 is 1/4. And let's see the other one. With plus. So the point I'm making, and I'm going to write this down for you. When you use the calculator, so the other one is 2. When you use the calculator to determine the solutions using the quadratic formula, so we have y equals negative b plus or minus b squared minus 4 times 4 is 16 times 2 is negative 32 over 2 times 4, which is 8. In the graphing calculator, you may get away without putting parentheses. You may get away without putting parentheses here depending on how recent your calculator is. I will always put parentheses, even in the software. I don't trust it. But this is mandatory. These are mandatory because if you don't put them, the calculator will give you totally erroneous solutions. So now I know that y equals t minus 1. So this equation is t minus 1 equals 1/4. And this equation is t minus 1 equals 2. And that's how I determine t. I should have asked you from the very beginning, how many solutions and what is this is still a polynomial equation. How many solutions do you think we're going to get? Yes, because it's t squared. There is nothing else, right? So we expect 2 solutions. So we move 1 to the other side. So one solution would be 1 plus 1/4, and the other solution would be 3. So this one is 5/4. So this is one solution, and this is the second one that we expected. Questions for me, please? Anything? Anything? Last type. Last type is equations that have rational exponents. And you could say, well, but that's a radical. You just told us last time that any fractional exponents are radical. Yes, you can change it into a radical equation if you want to. Let's see if we don't. But yes, you can. So equations with rational exponents. Equations with rational exponents. Okay, so let's say they selected 7, 9, and 11. So let's do 6 on 141 and the book. So we have x to 2/3 equals 16. I don't recommend you taking both sides of the equation to which power? 3/2, right? I don't recommend that. I recommend doing it in 2 steps. I recommend first raising it to a power that will eliminate this. What power will eliminate this denominator?
3.
Yes, let's do it in 2 steps, and I'll explain why. So then we have x on the left-hand side. What is left?
X squared.
Perfect. And on the other side, if anyone can give us 16 cubed, I'll appreciate it.
4,096.
4,096. Now, what type of equation is this? Quadratic. This one is quadratic. How many solutions do we expect?
2.
Very good. So then from here we have x equals.
Plus or minus.
Very good. Thank you.
64.
Plus or minus.
Okay. Let's take a look at. Oh, remember one thing, we raised to the 3rd power, we should go back and check. But every time we raise to an odd power, they will both work. Okay, so Please go back and check, but you will see that both work. Let's take a look at 11. X to 2/3 minus 5x to 1/3 plus 6 equals 0. Yes, you would say this is a radical equation, and I would have to say yes, but we cannot solve it as a radical equation unless we I shouldn't say we cannot. We can. We have to separate the radicals. But who wants to raise both sides to the third power with a binomial? A binomial to the second power is 3 terms. A binomial to the third power is, you don't want to work with those, especially with radicals. So no, it is a radical equation, but we will not solve it as a radical equation. Any suggestions?
Cube both sides.
Say it again.
Cube both sides.
I don't want to. That's what I was saying. If I move 6, or if I move one of them, I saw that 1 second. If I move any term to this side, I will have a binomial to the third power, which is 4 terms, and all of them will have radicals in it. No. Yes. Right? Okay. Yes. Right?
I don't know if this is right, but couldn't you just cube root both of the x's and make it x squared?
I cannot, they're not. See, this looks like this. The cube root of x squared minus 5, the cube root of x plus 6. They're not like terms. There's nothing I can do here. But there is a way. Yes, please. Flynn?
Can you multiply both sides by the x squared of 3/2?
No. If I do, this will become x. This will become the cube root of x squared. And this will become 6, the cube root of x. I didn't accomplish anything. Good. Next option. We looked at it 3 minutes ago. Yes.
Can you move?
Nope. We looked at the method 3 minutes ago.
Oh, we replaced.
Yes. Yes. We say let t be the cube root of x only when and if this is. If it is not, the method fails. Only if this can be replaced by of course. If it cannot be replaced by t squared, the method does not work. It cannot be applied. But the question is, if I square this, do I get that?
No.
Of course I do. So x to 1/3 squared, I copy the base, multiply the exponents, and I get 2/3. It's the only way. So the equation is t squared minus 5t plus 6 equals 0. Yes, so here we are combining, we're using the method that we just discussed, because this equation is not only a radical equation, but it's quadratic in form. We can replace it by a quadratic equation, right? So now, yes, let's factor it. Can anyone give us the factored form of this?
T plus 1, t minus 6.
Of course, excellent. T minus 2, t minus 3. If you said something else, I'm sorry, I apologize. T equals 2, that's okay. So, because the sum is -5 and the product is 6. So now, can anyone give us 2 new equations that we need to solve?
That's 1/3 equals 2.
The cube root of x equals 2, and the cube root of x equals 3. Did you understand the difficulties with this equation, that we could not do anything else but using the substitution? Is that clear? There was no other way. We can move terms, we can, yes, please. Yes. We can do anything here. And of course, we are going to cube both sides now. And we get x equals 8 and x equals 27.
So
Yes, please. Hold on, wait 1 second.
Why did we square only x to the 1/3? I'm so confused for that. That x to the 1/3 power squared equals.
What are the left?
to show that this is t squared.
Oh, to show that they're multiple.
I just wanted to show, prove to you that when we square this, we get that. So therefore, it's legitimate to replace this quantity by t squared, this quantity by t, and then 6, and then 0. This was just an explanation. Because I asked, is this t squared? And some of you were not sure, so I needed to show that it was t squared.
Do we
Good.
have to check that every time?
No, you don't. You don't have to show it, but before you apply the method, you have to make sure that one term has t or y or z, whatever variable you want to use, and the other one has squared. Because otherwise, you cannot use the method. Right? So if I change this, let's say I change it into 4/3, the method doesn't work. Because this will not be a square of this.
So what would you have to do then?
Graphing calculator. I don't have any other method for something like that. Very good question.
And
Good.
Were you also saying that if you were gonna just cube the entire thing, that's possible? It just takes
No.
too long to do and you wouldn't
No,
have to
let's
do
do it. Let's do it. So you want the cube root of x squared minus 5, the cube root of x plus 6 equals 0. So are we finished with the problem? Is it clear? Yes?
Yes.